Hello everyone. Today is day 21 of our 30 of us solving 30 problems in 30 days. So this is about uh, to deploy a machine learning model using Flask and Heroku for real-time prediction. So I'll be changing it a little. I am not experienced in Flask. I have used FastAPI before, and also fast API is faster than uh, Flask, and I have two more reasons to go for fast API, which is to it is easy to implement, and the API documentation is already being created by default with fast API. So I'll be going ahead with using fast API here for building the APIs, and deployment again is going to go with the Heroku. Now, which model are we going to deploy? So, I'm thinking of using an existing model that we have built in past 20 days. So, I'm thinking of going ahead with problem 8, as in day 8 problem, which is to detect fake news with a passive aggressive classifier and TF-IDF vectorizer. So if I go here, what was this problem about, and why do I think we should go ahead with this problem for today? Is for the simplicity of testing it with our API. So with our API, we'll just pass the text of the tweet, and we are going to check what the label comes as in, is it going to be a fake one or is it going to be not fake. So that's why I'm going ahead with this problem. And to just revise what we did on this problem, to solve this problem, we got the data set from Kaggle. This was the problem, and this is how the data set looked. It had two CSV files, fake.csv, true.csv, and we combined it into a single CSV file. So what we did, we loaded the fake data CSV file and true data CSV file and stored it into fake data frame and true data frame. We prepared the data by mentioning the label in the label. So we added a new column in our fake data frame and called it label, and stored it as 0 because the news are fake. And then for true news is, we added the label column with values 1 for true news. Now what we did, we concatenated both the data frames into a single data frames and concatenated on column, and then we reset the index because we are putting the fake one on the top of, so below true one, so we are putting fake below true. So we wanted to refresh, give a new index, right? And what we want to do, we want to remove the original uh, uh, we want to remove the uh, original indexes stored in a different column. So I have already explained this in depth on day 8, and the video is already there on this post, so you guys can go and check out. So I'll not go and explain this in depth. I'll simply iterate it for the sake of this problem, as in today's for deploying. So we concatenated and stored in a data frame called df. Then now the data frame has this label and text. So the text is going to be our features, and the labels are going to be our target. Then we since this is a textual data, and machine learning does not understand textual data, so we have to convert it into a numeric form. So how do we do that? We use TF-IDF vectorizer. TF-IDF vectorizer is, the full form is term frequency and inverse document frequency. So what it does, it calculates how often a word appears in a document by getting the frequency of the word, that is the number of times a word has appeared in the document D, and the total number of terms in the document D. So for example, in a document, news has appeared 5 times, and the document contains 100 words. So it is going to be, the TF value is going to be 5 by 100, it is going to be 0.05. And the inverse document frequency IDF measures how important a word is across all the documents. For example, the word deep, and how does it calculate it? We can look at that first. So it calculates the total number of documents there are in the data set, and the number of word documents containing the word T or term T. So, for example, there are 100 documents only, and only 5 documents contain the word news. So, it is going to be 100 by 5, and we do logarithmic of it. So, this is how we get the inverse document frequency. And with this, what we do, we filter out and we get the importance of the word. So, how unique the word is. For example, to say a bomb. Bomb is a unique word. It should not appear in most of the documents, and we can use this frequency of how unique the word is to detect if the news was fake or true. So that is why and the other example is the inverse document frequency value for the is going to be very less, so which will say that it is not an important word. Okay, so that is why we calculate a dictionary using TF-IDF, and then we create a dictionary out of TF-IDF, sorry, and then we train it on that vectorizer. Once done, we split the data into training and validation. We go ahead with 80% of training data and 20% of validation data, and then we train the model using passive aggressive classifier. Why we went ahead with passive aggressive classifier is because we wanted to learn from our mistakes. So this model, what it does, it learns from its mistakes, where we specify how many iteration it has to do. So we say, okay, we have to do 10 iteration, and it says it is a great real time detection task for fake news, where we say you have to do 10 iterations, and from each iteration you have to learn from your previous mistake. Okay, so this is why it is called passive aggressive classifier. And then we predict the model, and then we visualize. For this problem, what we will do, we will only predict. We will not predict, we will predict in our API. We are going to just train the model, right? So I'm going to say, let me go, close it and close it and close it, and let me go and do what this I'm going to say. I'll go and open the day 8 problem and say, hi, today is day 21, and this is the problem title. I'll copy the problem title, and here I'll change Flask to Fast API. I've told you the reason. And this is the model I am thinking to go ahead with. Let me copy what I have been copying, and help me with uh, the full flow for solving today's problem. So let's see what it says. Okay, so it says that it is a great uh, problem to deploy FastAPI and Heroku for real-time prediction. Here is a step by step. Finalize and save the model. Since you have already built and trained the model, next step is to save it along with the TF-IDF. So we are going to save the model. Just give me a second. You must be hearing some background noise. I need to close the window. Okay, thank you. So yes, it says that we have already built the model. So now we have to save the model and the TF-IDF vectorizer using pickle. This will allow us to load the model and vectorize in the FastAPI. So we have to save the model using pickle. So I will go and Google about this model. Pickle is a module implementation binary protocol for serialization and serializing and deserializing a Python object structure. Okay, so I need to ask, why do we need pickle? I'll simply ask, why do we need pickle? So it says we need pickle in Python to serialize and save machine learning models and other Python objects to disk. This allows us to store trained models and use them later without having to retrain them. Okay, so we are going to use it to save our model and TF-IDF vectorizer, which is going to use to, you know, convert a text into a numeric form. Especially when deploying a machine learning model using FastAPI, which is a framework or any other framework, we need pre-trained model and their vectorizers to make predictions in real time. So that is why we are using Pickle. So let's go back. Let's go back. So I'm going to do what? So I'll have to import Pickle. I'll have to say okay, save the trained model with okay, Tizer. uh, they can be uploaded in the fast API. So okay, we have to save the model in the this file, and we have to save the. So okay, so let's do what, fake news API. We'll create a folder like this. We'll have our fast API in this. Then the model will be saved in this. TF-IDF will be saved in this, and the requirement is going to be in this. Proc file is going to be this, and runtime.this. Can you explain how will how will I save the this code to model.pkl and this tfidf vectorizer.pkl, and this is the code. I'll copy and paste it. It says you can save the pickle library in Python. After training the model vectorizers, you can serialize and save them to disk. This way, you can load them later in your FastAPI app or any other application for making. So we have to save them in the disk by serializing. So I need to see how we are going to serialize. So it says the full code with saving model and vectorizer is going to be this. This is going to be our existing code. Okay, and once we have fit the model, we are going to save it. So we will do what, you load the dataset, pre-process the text using tfidf vectorizer and split the data into training. You train the passive aggressive classifier model on training the data, saving the data. After training the model.fit, you save the model object using pickle. So we are training the model and we will save it using pickle. uh, this is done after running. Yes, they store the model in a file called model.pickle, so you can load it later with the. Okay, so I guess after running this file, this will create a model file like pkl.file pickle file like this, and we will save the as model file and dump the model into that. Same it will do for our vectorizer. And loading the model vectorizer in FastAPI or any other application, we would do what? We would do same thing with open as model file, pickle dump. No, with open as model file, we are going to pickle load the model. Okay, not dumping, load the model, and then we are going to do this rest. Okay, let's start. So what I'm doing here, I'll create a new folder. I'll say this is going to be day 21. It is going to be our day 21, and here it is going to be a new file called Python file, model. I'll call it as, let me go back here, and here I'll go come here. Mm-hmm, mm-hmm, mm-hmm. um, Model day a code, model code. So I'll say training code. So this is pre-processing dot. This is model training, or what I'll say, model training dot py, and here I'll add it to my repository. I'll copy and paste the data. I'm simply going to do what? I'll go data. So here the spelling is wrong, and what I'm going to do, I'm going to test it once, right? So I'm going to do what? Remove this uh, visualization libraries used for visualization. That is it. That is it. That is it. Okay, this is it. This sounds great. So I'm going to do what? Going to go to our day 21, and here I'm going to run this model train.py, and I think it should throw error. And it did throw it because I'll have to do this, and now I think this is going to work. Now this is working, right? This is working. Okay, so it says the maximum iteration reached before convergence. So we should improve the iteration count. So let me go to the model training and let me increase it to 20, and let me run it again. Okay, so it is working fine. So now let's save it to as pickle files. So let me go to my this code and import the pickle. Import pickle to save the model and vectorizer as what? Let me go back here to save the model as save. Huh. Save the trained model and vectorizer as trained as to use later at run real time prediction. Okay, so let me go back and give two spaces first of all, and here what I'm going to do, use pickle to save the model and trained model and what, vectorizer for using it in FastAPI application. Okay, so what we are going to do, let me come here. With open a model, not here, with open model.pk plk, with this thing, and as model file, and this pickle dot dump. What we are going to do, this model we are going to dump in the model file. Yes, and then with open vectorizer, or what we can say, tf idf vectorizer, tf idf vectorizer, as this vectorizer, and pickle dump our tf idf vectorizer as in this vectorizer file. And I'm going to say print model file and tf-idf vectorizer are stored in the model.plk and plk files. So I'm going to run this model training.py file. Either it is going to throw error or it is going to save it, and it has created the model.pk. Let me open it. Okay, it is not, I cannot open it. And the tf-idf dot plk plk dot pickle pkl dot pkl plk, not pkl. I'm going to delete this as well. Delete. Going to come here, delete. Terminal, I say delete. I cannot delete it, maybe. I don't know what is the issue with this file. I'll go and open the terminal again and run this file model training again. Now it should create uh, the model, and yes. I don't know why I cannot delete it. Maybe I can try removing this tf-idf file here, and I have removed it from the terminal. Wow. Yes, so we do have the model and vectorizer saved in the pickle file. Now, what we are going to do, we are going to create our fast API and use it to build our APIs. So what we are going to do? Yes, we are going to load the model and vectorize it in FastAPI or any other application. Not this one. Here we should go. So we have imported it. Now create the FastAPI app. So what we have done, we did this day 21 main.py where we are going to store the model.pkl done, tfidf dot underscore vectorizer done. This we will create, this we will create, this we will create later. This is what we are going to do now. So I'm going to create a file called python file main.py and add it to our repository. And from FastAPI, I don't think it has this API. pip import pip install done. Sorry, it's what. Okay, FastAPI import FastAPI. Then I'm going to do pydantic install it. Import pip install pydantic. It has it. From pydantic import base model to build the base model, the base structure of our classes for our APIs. Import pickle to load the model and vectorizer, and import numpy to do the operations as np, and what operation we'll see later. First we are going to do initialize the fast API app. So what we are going to do, app is going to fast API, and here we are doing the title of our fast API is going to be fast detection API, fake news detection API version 1.0. And we will do what we are going to specify, load the model and vectorizer, load the model and vectorizer, load what model, train model and vectorizer. So with open the file that is model dot model dot pkl, and open it with not write, with read permission as model file. Model is going to be our pickle dot load this model file. Then we are going to do open this file tfidf.pkl for reading as tfidf file, tfidf vectorizer file, and we are going to do tfidf vectorizer and load it using the pickle load function, this file. Now we are done with loading our tfidf vectorizer and the model. Now what we are going to do, define the request body structure using pydantic. Yes, so I've told you that we are going to have a model, right? We are going to have a model, sorry, we are going to have the base structure of our APIs that we are going to store using the base model. So going to create the request body structure using pydantic. Define the basic structure of our body using pydantic. We, you know what, we can do it even without using this base model. I'll tell you later, but let's go ahead with what the this chat GPT says news article based model. Here we say this. You know why we do this? Because it helps in validation. It helps in validation by default, so it saves a lot of time. So yes, so it says okay. Now let's come here. Define the prediction. Now we are going to have endpoints for our APIs. So what we are going to do? We are going to have a endpoint for endpoint or API for uh, for what prediction? Prediction. Define the endpoint for prediction. Endpoint. Define the prediction endpoint. Prediction endpoint. Our API. So what we are going to do? App dot. So this we are going to do app dot, which is going to be of post type. That is why we, so if we would have taken it into as, no, I guess with even, yeah, with as get request, you would have worked without using defining the base model. So for our post type this request, we are going ahead with defining our base model. So we will do what, this is going to be the endpoint, and the request, the API is going to be of post type, and the function to handle, the callback function to handle this is make prediction. And here we are getting what, we are getting article of news article type. And what was news article? This is the type of news article. So this is going to take care of making sure that the news article will have text and will have text of string type, the validation. So what we are doing now, we'll come here, vectorize the income text income. So what we are doing now, vectorize the incoming text. So what we'll do, we'll go to our model training. If you remember what we did, uh, we fit transform, right? We are going to do something similar. So what we are going to do, we have built our vocabulary, so now we are going to fit this. So what we are going to do, um, vectorized text, and we are going to do use the tfidf vectorizer dot form. We are going to transform you what it expects in two dimensions. Why I've told you in the date video also, solving that problem, that since there are going to be multiple features, so it expects for consistency to have multiple features, that is multi-dimension. That is why we are going ahead with, even though we have only one dimension here, which is the text, we will pass it as multi-dimension. This is how the vectorizer expects. So we are saying article dot text, this is the class variable. And now we have got this vectorizer text, we are going to make prediction, and model dot predict, and we will predict using our vectorizer test, and return the result. Return the result. So we'll do what, result is, if we remember what we were getting here, let me go back to our day number 8. What was the expected output? The expected output was coming as 0 or 1, right? So I'll go and I'll say, come back here, if, so it is going to be fake if the we are going to store the prediction here in this variable. If the prediction value is going to be zero, it is going to be fake, else it is going to be true. It is a true news, it is not fake. And return the response from this API. The prediction is result. Correct? Correct. Now we have built our API, the prediction API. Um, let's build the home of our application. So home is going to be a get type request. So I'll say build the home page of our application. So what we are going to do, we will do what? We'll say the app dot get, and it is going to be the home, and we'll say def uh, home index, we can call as read root, or we can call as index also. I've seen it somewhere that we call it index, and we return it as return. The message is welcome to fake news detection API. Visit docs for swagger documentation. Okay, going to copy it so that it saves the time. This is says that welcome to the fake news detection API. We need to visit the docs for segment documentation, and you know what? With Fast API, the documentation comes built in, so we do not have to invest any or write any code for building the documentation of our API. You'll see it soon. So let's do what? I guess let's create a requirement.txt, a new file called requirement.txt, requirement.txt, add it to our git repository requirements requirements, refactor it requirements. You need, so we are going to list all the dependency our project needs. So FastAPI needs UVCon, we have not installed, so we need to install that. Let me go what pip install. This we already have this, we already have gun unicorn, we don't have. Do Why do we need the gun unicorn? I'm not going to install it unless it says. I'm going to copy it and paste it here. Paste everything here. I'm not going to use the gun unicorn. So it says Heroku. I'll say what is Heroku. I'll simply Google it once. Heroku is a cloud platform as a service supporting several programming language. It is as one of the cloud platforms. Heroku has been in development since 2007 when it supported only the programming language Ruby, but now also supports Java, Node.js, Scala, Clojure, Python, PHP, and Go. So it is a cloud platform to run the programming languages, the code. So it says Heroku needs proc file to understand how to run the application. So that is why we need this gun con. So I'm going to import this also. So Heroku needs this proc file to understand how to run our application. So what we are going to do, we are going to file this command. This specifies 4 worker processes for handling multiple requests. Okay. Uses UVCon workers to handle. Okay. But I don't think, do we need the Heroku? Let me see. I think I'm going to follow it. I have built applications without Heroku. I have deployed it without Heroku on AWS. So I don't think, I guess we can run this fast API without the need of Heroku. But I'll follow along this tutorial, and at the end I'll experiment if we can do it even without Heroku or not. So yes, and UVCon. Why do we need UVCon? Because this is going to provide the server. to easily run our fast API applications. So uses unicorn workers to handle the asynchronous applications. So yes, let's run this code. So I guess I need to write this proc file, right? I guess yes, Heroku process. So I'm going to create a new file, proc file, add it to our repository. It is going to procfile. I'm going to paste this command that Heroku needs to run this application. So it is going to run this application using this. I'm going to install this gun uh, gun icon, and yes, I have everything set up. Specify the Python version. We can specify the Python version using runtime.txt. So Python is pyth. My version is 3.8.9. So I'll specify you in the file called requirement runtime.txt. Runtime.txt, add it to our folder, and this is going to be our python python version 3.8.9. That's what we are running now. Initialize the git and push to Heroku. Create new app. I don't have Heroku. Then how do I push it? Is it possible? I'll say, can I run this application on my, I know I can, local first before pushing to Heroku? Yes, that's what I'm saying. We all have everything run. Why I am curious, why we didn't install this numpy? We do not need this numpy, right? Yes. So what I'm going to do, I'm going to run this application locally. We do not need Heroku for it, right? So I'm going to go here. It says, see, we have we are able to run this application on our local. I was right. We do not need to Heroku. We can test it on our local and then push it to Heroku, right? So yes, let me. It says we can go to our docs, and I can go to the docs, and it says internal server error slash OPI. I says, so it worked, but on going to slash docs it says internal server error. So what we can do, we can check our API. Maybe what we can do, maybe we can hide this. We do not need this. We can hide this. We do not need this. Let me go. It still says, mm, let me hide this also. I do not need it right now. Input should be a valid string. The error is pydentic core pydentic. Here we have error with pydentic, uh, and it says input is a validation string. This is the error. Sorry, this is the error. The error is related to open API generation. So what we can do. Yes, this was the error. Maybe we do not see. Okay, see, it is working now. So let's go uncomment the whole code. Our code for the prediction API, then the code for this loading our vectorization model, and this defining the base model for our this prediction news article. And we are going to go to this post. What we are going to do, I'll remove it. Thanks. I'll go and test it. What do you want today? Thanks. It worked. Now, which news should I test with? Give me few examples. Yes. Fake news. It should be a fake news. What it says, let me try it out. And this body is string types. It says scientists have discovered that chocolate cures cancer. After extensive studies, researchers found that consuming dark chocolates every day could completely eliminate cancer cells from the body. This breakthrough could revolutionize the world of what was the, I guess, I guess this was a fake news detection, right? So I'll test it. Execute. And it is a fake news. Correct. We have correctly detected it. And real news. So let me go and use it. Let me go again, and here I am going to pass it like this. The news Congress passed the US Congress passed a 1.9 trillion COVID-19 relief package on Wednesday, and was signed by Joe Biden. So let's do what executed. This is also, so this is also coming as fake. True. Real news. Let me use this. Uh, if everything is coming as fake news, let me go and get this thing from the data itself. If we remember, we got the data like true news, right? Let me go and read the news. uh, as US budget fight looms, publication flip their fiscal scripts. I'm going to use this as our real news, right? Because this is this is how it should predict. uh, it is also categorized as fake. This is true news, right? What I should do, I should first go to this model training. And here what we are going to do, I'm going to open this file. I'm going to get to this fake news, true news, and going to get the text, right? From here, what are we in the model training? What we use the text. So this is our text. So we are going to go with this. and see what it says. And here I'm going to get this true news. Yes, correct. I've got this. I'll go. You know what? Do what? I'll get where is it correctly predicting, right? For which it is correctly predicting. I'll get some data. I'll go to this model training. I'll comment this thing for now. I'll not save because it is already saved. And I'll do what? Model. I'll print and I'll comment this also. You know what? I'll comment this also. This also. I'll not build anything. And here what I'm going to do. Here what I'm going to do. I'm going to print x dot head x simple. And we are going to do sorry 2 dot x and going to run this file and in a new terminal. Hmm. Maybe I can stop it, right? I've suspended it. Let me run this Python file model training and see what this has. And if I want to see the text only, so this is the string and this is what it should do. I should go here and I should do one and I should do two and I should comment it, uncomment these two, uncomment and uncomment and uncomment this. And let me run this file, this my this code again. This says that it is already in use, so I'll have to do this exit open the terminal, run this again. I should go open the files. It says it cannot find the okay. I have to exit it, exit, exit, open the terminal, go to our day 21 and then run this. Then this FastAPI code and here I should be able to do yes what yeah and this is the CSV file. I'll use I'll use what? So I've closed the terminal. I cannot see, so it did not work, but I did. So what I'm going to do, I'm going to go to my folder, and here I'm going to go back maybe 30 days. Not here, not here, not here. Um, so what I can do, I can say, um, hmm, I need to test it, right? I'll say this is the file. The it it is not working good with predicting real news. Should I give this is the true.csv data set I have used to predict to train the model. Train the model. Can you give me few examples to test the model on real news from the CSV? I'll download it. I'll go to this to not. I'll go here, go to my download folders, and this unzip it, and go to this upload this true.csv. It is a little large file, so let me ask this only. Maybe I can open this opening. Send this to ChatGPT. I guess this has opened in this form. So what I can go, I can try out this thing on couple of news which are true. So it is a true news. Okay, so I'll stop. Okay, I will not save it. I'll stop. So it has worked. It has correctly predicted this news as true news. So then I can go and similarly try for some news from the data set which are fake news. So I can go download the false news. Where's the news? Where is the yes? Go to the data set. Go to the data set, and here this is going to be false news. I'm going to download it, and this is getting downloaded. Unzip it, open it in the uh, yeah numbers software. Get the news from this, the text from this, which is mentioned as fake news in the dataset. Now come back here, mention it here, and then try it out, execute it. This should be fake. So our model is correctly predicting the fake and false news using this API. Now the step is to simply go and deploy on Heroku. This was part of the today's challenge. So let me see. I need to tell. Cool. It has worked. I can test the news as fake and true as true correctly. Now I don't have Heroku signed up and on my Mac. Can you tell me what all I need to put deploy it on Heroku? Install Git. I have the Git version. Install Heroku. I can get the install Heroku. Sign up for Heroku. I don't have the Heroku. I can sign up the okay, I have it everything. I then need a proc file, create an Heroku app, deploy to Heroku, test your app. So this is what it says. I need to go and create an account on Heroku first. So let me go. If it is going to be a quick thing, I'll do it. If not, maybe after solving this thing, we just need. I mean, it is not going to be a challenge. If it is going to take like few hours, I will not do this in this video. I'll stop it right away because this is all about creating an account, pushing the Git repository, and once done, it will give you a URL, and just we need to hit the URL using curl. And this will do something similar to what we did here on this page. So yes, let me go and see if the A step is easy to create an account on Heroku. I'll go back here. Heroku deploy with Heroku. Sign up. So it is going to be a little bit lengthy task, I see. So I'll stop the video, close the video for today because we see it is working. The API is working. We just have to deploy it on Heroku, right? And we can do so by doing these many steps, and maybe in future we can deploy all the projects using these steps. So thank you very much. I'll do what, I'll create a do go to my this, and I'll go and create a new file. I'll say Heroku deployment steps, and this is a text file. I'll save everything here, and then I'm going to do what, I'm going to close the CSV. I will not delete it. I'll delete it, and I'm going to close it. This is how it is looking. Close it. Go, come back to our PyCharm, suspend this job, exit from here, and open the terminal again. Go to our day 21 and commit this code. So I'll go add everything here. I'll see, and you know what, and commit. I should not add this model.pkl. So git restore this model.pkl, and let me do this git status. Git restore staged model.pkl and tfidf.pkl. Do git stace. Okay, so yes, this is how the data is looking. And let me add everything. I've added everything, the steps, the main file, the model training, and everything. Now I'm committed. Commit. Add code. Fast API code and model training code for day 21, and push it to our main branch. So I today I'm really happy with what we have achieved today. We learned how to store our models, trained models and vectorizers using Pickle, and then how to use it in an external API, sorry, application like Fast API. We also see we could have used Flask. Fast API was easy for me because I've already used it, and so yes. And it fast API is faster also for other reason, and easy to implement. We also saw tested it on couple of scenarios of fake and, let's come back here, fake and non-fake, as in true news, and it worked fine, our API. We also saw that I do not have Heroku website or account created on Heroku, so I do have to go and create that. But we saw how to do it, like a usual step. We have created the files needed for Heroku to deploy and run, like the proc file. So this is all good. This is a good day. And I'll go publish this video, and I'll go write a progress post about it, so that I can come and revise the problems that that we have solved together. I have solved in this challenge. So thank you very much.